Local check 1, 2. Okay, here we go. It's Tuesday, September the 24th, and we're in the lab session in SPS 1125, and we're going to do the run through for this lab, DHCP version 4, lab 7.4.2. And if you guys that are here look at the overhead screen, you guys that are looking remotely, it's on your Blackboard Collaborate. I have PCA and PCB. And I didn't mention this real clearly last time during the lecture on Tuesday, but what happens when you have a workstation configured for DHCP, which is the normal default? The button is clicked that says attend the IP address automatically. I'll show it on this one. So go into Properties and IP version 4, and the button is clicked that says obtain an IP address automatically. So that means there's no static setting on this workstation. He's going to look to the DHCP server. He's going to broadcast the request out to the DHCP server to give us an address. And you guys are going to configure that. Well, my machines, both my routers are erased. So there's no configuration here. But look here a second. Looky here. This sort of happened when I did this on Packet Tracer. If I type ipconfig, I think I just typed ipconfig. It has a kind of an IP address. Look, 169.254.200.213. That's a special reserved address so that if you're working on, if you have the auditors are in the conference room and they plug all their laptops together and there's no DHCP server connecting them, they'll get all configuration IP addresses where they can share information with each other. So Microsoft generously donated this 169.254/16 prefix to the world for use in this automatic IP address assignment, I think is what the official protocol is called. So if you see that on the workstation and it's configured to be DHCP, that means he's trying to talk to the DHCP server, he just can't get in touch with them. Well, of course not, we have not configured it yet. Okay, so I'm going to do this sort of step-by-step like he has in the order of the lab this time. Instead of skipping ahead, I did some stuff sort of out of order last time. So you don't have to do any manual subnetting of your own. He's done all the subnetting for you and given you the subnets you're going to use on the various networks that are in this lab. And that's all detailed on pages 2 and 3 where they've done this stuff. So I'm going to go to the top of page 3 and start configuring the routers. So let's see, let's go to TerraTerm, COM1, and TerraTerm, COM4, and these should be our routers. Okay. It was plugged into the switch, that's why it says switch. I only have 2 wires. I don't have 2 workstations. I'm going to have to do what the phone guys call swinging cable, swinging wire, to go back and forth. First of all, I'm plugged in R1, R2. I'll do those. And then I'll swing my cables up to the switches when we get to that part of the lab. So this kind of looks like an erase router, doesn't it? We'll say no on this one. We'll say no on this one. And then confirm it's actually a router, because when it comes up, it should have the default host name for a router is the word router. The default host name for a switch is the word switch. So he's going to come up here. Any second now, he's going to be done with this little rep subroutine. Okay, it's a router. It says router, router, router. And just to prove there's no existing configuration, we'll go to the privileged exec mode and let's show the startup configuration file. So on a router, that's the way we can be assured there's nothing in the router. Now, when I set this up this morning, half the routers had a pre-existing configuration in them. I had to erase them and reload them. Okay, so instructions. I'm doing step 3 at near the top of page 3, and we're going to assign the device name to this router. So I'll get to the global configuration mode, and I'll say hostname R1, and the prompt changes instantly. Now the command no IP domain lookup. That way, if we mistype a command, we're not stuck in the penalty zone for a minute while he tries to look it up. And then let's set the enable secret class. And then line console 0, password Cisco, and then login. You can do it out of order, but you get that annoying message. Line VTY 0 through 4. If I do login first, I get the annoying message that the password hasn't been set yet. Password Cisco. You can do it by either order. It works just the same. It's just annoying error messages. So Cisco annoyances. Okay, step F, a little bit under the middle of the page. I'm going to do the service password encryption command. I'll go back to the pure global configuration mode here. This password encryption, and that way the password Cisco for the console port and for the VTY ports, now it won't show up in plain text when you do short run, and someone can't look over your shoulder and see that. Okay, and banner message of the day. Message of the day. He uses he's just in the $sign. I'll do what he does. You can use any delimiter character you want to, just so long as it doesn't appear within the message, because he sees that $sign, and when he sees a second $sign, he's going to print between the two $signs. So if you put a $sign in your message, you wouldn't see what's at the end. So use some unique delimiter command that he won't see. Whatever you want to say here. Now, if this works, then when we log out of the machine and log back in, we receive the warning message, and then we're prompted to put in our password Cisco. And then when we go to the privileged ZIC mode, we're prompted to put in the password class, and the passwords are working. And do a copy run start. Right, WR is shorthand for copy running start. You don't have to press enter once. I'm not going to set the clock. The clocks are fine. You guys can skip the clock if you want to. The clock in the lab is wrong because this lab was printed up last year by the Cisco Academy people. They write the curriculum. Okay, now we're going to go to, warning, Will Robinson. This lab was written for the 4321 newer model Cisco routers that actually are Linux machines. And their interface port numbering is G0/0/0 and G0/0/1. On our routers, our 1941 routers, it's G0/0 and G0/1. If you try to type interface G0/0/0 on these routers, they're going to come back and say, what is this? They'll give you an error. So if I go to the global configuration mode and try to type interface G0/0/0, like it says in the lab, I don't know that. So just 2 zeros. Oh, he says I'm supposed to go to 001. I'm sorry. Interface G0/1. If I'm changing to config-F, and he wants us to do a no shutdown command. I have already done the no shutdown on the G00 ports because I was testing with Cisco Discovery Protocol to make sure that I had connected the wires properly. I think the wires are okay. Okay, I'm at the top of page 4, and we're going to configure sub interfaces. We're going to create some VLANs on the switches. We haven't gone to the switches yet. We'll do that later. We're going to do the routers first. So he has instructed us to go to router 1. I'm still at R1. I'm at R1, and I'm going to go to the config mode, configure terminal, and interface G gigabit 0/0/1. This is confusing. .100. 0/1.100. It's one of the shutdown. Okay, description keyword, and this is the clients. And then encapsulation .1Q, and the VLAN number is 100. So normally we make the sub interface number .100 and the VLAN number 100, and maybe the third octet, the IP address 100. We make those the same so that there's no reason you have to do this. You're not required to do this. This makes it easier to troubleshoot later. It makes it more consistent. Okay, and now we're going to give out IP address. And this IP address is 192.168.1.1. Oops. And it's 255.255.255. Yeah, I'm still recording. Good. All right, now interface G0/1.200. Encapsulation .1Q 200. Assign the trunking VLAN number to that. And the description keyword is the management. Or manglement, if you prefer. Managers typically, is anybody here a high-level manager? I don't want to insult anybody in here. Sometimes I insult people. I ask the question, do you work for the cable company? I don't want to insult you yet, because the people that work for the cable company, the people who couldn't get a job at the phone company, it's like a Don Rickles thing. It's all in fun. Okay, so description, management, and let's get my IP address. 192.168.1.65 224. So this is That's your muscle memory. That's you up here, guys, because you're so used to typing 255.255.255.0 for your subnet mask for /24. But in this lab, they've got some subnet masks that are smaller than 24s. So they have a different subnet mask that are present. Okay, interface G0/1.1000. That's going to be our native VLAN. So ncap.1q1000 and native. And we'll change those on the switches, and we'll get all those pesky messages because they won't until we get them all matched up. Description, native. Now, if I should do a show IP interface brief here, remember that when you have sub-interfaces, you don't do a shutdown and no shutdown on them individually. You do the no shutdown on the master physical one port that they're actually connected to. In this case, G0/1 has been done a no shutdown. And if you notice here, he doesn't have an IP address. You normally don't assign an IP address to an interface that you've sub-interfaced into different ones. You assign the IP addresses to the sub-interfaces. So I have no ability to bring up and down the individual sub-interfaces. I have to bring up and down the parent interface that's been sub-interfaced into. Nothing confusing about that. Okay, let's see. I'm supposed to go to R2 now. And has he skipped some steps here? So here's R2. Let's just prove that I'm connected back properly. This is what I did on you guys' secondary workstations just to prove that things were okay. Did I do a shutdown on? I got to do this. Here's what I'm going to prove this here. I'll go to configuration mode. I'll go to interface gigabit Ethernet 0/0, and I'm just going to do no shutdown on it just for now. So it'll work with Cisco Discovery Protocol. And then I'll go to router R2. I'll go to the privilege exec mode and do the global configuration and give them the host name of R2. And then if we do, oops. Everything's administratively shut down by default. So I need to go to that G001, and all I want to do is just do a no shutdown on it so that they'll communicate back, and I can prove that R1 and R2 are connected to the proper ports. So that's what I did on all you guys' secondary workstation because I want to make sure I didn't create any wiring errors. R2, and let's see, configuration mode, interface G0/0, and do a no shutdown. We should see something pop up on both screens as R1 and R2, G0/0 go from R1 to R2, and they should come up here in a second. Looks like they both come up in sync with each other. So now if I go to R2 and say, show me your CDP neighbors, he says, oh, R2 says, my neighbor is R1. R2, my local interface on my R2 G0/0 connects to the G0/0 of R1. Good, that's what the lab says to do. Oh, good. So there's proper. So, like Reagan says, trust but verify. So we'll go back and we'll do a show CDP neighbor on the first one. And he's telling us that R2 is connected. What's this switch and switch? Oh, well, there's a 30-second like a memory on CDP neighbor, and I hadn't renamed it yet. So the switches are connected. The switches are connected to these ports. He's seeing the switches on there. Okay, nothing. When we do the switches, it'll be S1 and S2, but we haven't configured the switches yet. They should be in their default condition. Now I should be able to go. I just completed these preliminary steps. This was not in the lab steps. I just wanted to do this just to prove that my wiring was okay. Like I wanted to, don't want to slow you guys down because I made a wiring error. Okay, so I'm on step 5, down slightly below the halfway point of page 4. And we're going to configure the R2 router with some addresses. So R2 configuration mode and interface G0/1. He says 0/0/1. We have to do 0/1. IP address is determined to be 192.168.1.97, 255.255.255.240. In the shot, I may have already done that. And then we'll go to the global configuration mode. And we'll specify interface G0/0, just 2 zeros. The address he's telling us to use. I'm doing it backwards here. I'm still in R2. I'm doing step B, the lower half of step B, then I have to jump back to R1 and do the top half. So router B is 10.0.0.2 and 255.255.255.252. That's a kind of a subnet mask that you see a lot, a /30. That's if you're running IP version 4, you're going to run out of IP addresses. So normally a point-to-point link between two buildings, between two job sites, between two enterprise sites, you would use a /30 subnet mask because that's only 2 available IP addresses. Okay, so there's 4 IP addresses in the range. The first one is reserved for the network address. The last one is reserved for the broadcast function, so we use the first one in a second. So 10.0.0.2, 10.003 is the broadcast for that subnetwork. And let's see how I do in a shutdown. I bet I didn't shut down just in case I didn't. Now I'll go back and do it. I did it out of order. I'll go back to R1 and interface gigabit 0/0. And he's going to be 10.0.0.1. 5.2.5.2.5.2.5.2. All those typing. Why didn't Cisco let us type /30? You can do it in DHCP. You can do it in that. You can't do it here. All these software engineers. Now, just to prove connectivity here, G00 is 10.0.0.1, so I should be able to ping 10.0.0.2. And it works. Okay, good. So we did our IP addressing properly. Now, no fair default route information configuration is given to you. Well, we're not going to talk about default routes until a later chapter. Oh, well, at least he gives it to you so you can type it in. Okay, so I'm supposed to go to R1 now, and we're going to create a default route between the routers so they know how to find the networks. Routers don't need any routing dynamic or static routing information to route between their own directly connected interfaces. But if it's one or more away, we need to use a dynamic routing protocol, OSPF, or we need to enter static routing information so they know how to get there. So it'll be in that routing table. So on R1, I'm going to go to the configuration mode, and this is strange syntax we have not covered yet. Okay, just chill, it's okay. And then on R2, I'm going to enter the appropriate command for that one. So in 10 seconds, sneak preview of what we'll see in static routing. The command IP route places a static route in the routing table. 0.0.0.0 is a wildcard. Okay, you Windows guys, fire up your computer, go to the DOS prompt and say delete ****. What's that going to do? What's the ****? That's the wildcard. Delete ****, deletes all the files. So if you want to erase all the files in the subdirectory, erase all the files on a floppy or something, you say delete ****. It erases them all. Well, technically, not the hidden, the read-only, and the system attribute files. Those don't get erased. Those are harder to erase. So if you type delete **** on your Windows computer, you don't hose it immediately. Okay, so the IP route, the first one is the IP address network you're supporting. Well, 0.0.0.0 in IP networking is like ****. All values match. So I'm telling it, if you encounter any network destination with any subnet mask, send it to the 10.0.0.2, which is his neighboring router. On the second router, if you encounter any network value with any subnet mask, send it to 10.0.0.1, which from R2 is the path to R1. So now we should have connectivity between all the networks on R1 and R2. And we'll do this more in detail when we do the chapter on static routing. Okay, so let's see if I can verify this, if I did this correctly. On the top of page 5, we're going to do a ping command from the router and try to ping 192.168.1.97. Oh, it worked. Oh, good. So our static routing should be proper. And he says to do a copy run start. Or WR for short, for right mem. And I'm going to go, he didn't tell me to do it. I'm going to go ahead and do it on R2 in case I pull a plug or something and I don't have to type everything all over again. So it's like when you do something in Microsoft Word, Hick's rule of backing up. As often as you care or as seldom as you dare. Well, what, every paragraph, every 10 lines or something? you know, every minute or so, do a copy run start. When you're doing Microsoft Word and you don't want the computer to, you know, flash out and erase all an hour's worth of work, you should back it up now and then. Okay, I'm gonna swing cables now. And the switches are going to freak out because they have weird conflicting native VLAN information, but we'll fix that. Okay, so let's see. S2 is only configured with basic settings. All right. So he has a, let's do this one first. I'm going to go ahead and give it a host name. Does he tell us to do that? So this basic setting, I'm going to do this. Go to the privilege exec mode, configure terminal, and host name S1. So we know which one it is. Enable FMT, host name S2. Now let's go back to S1. Let's put this information in. Okay, VLAN 100, 100, right? Name clients. VLAN 200. Name management. Kind of did this last time, didn't we? The VLab seemed to have a sort of a standard on the VLANs. Okay, VLAN 999. That's our black hole VLAN. Name parking lot. And then VLAN 1000. Name, that's our native VLAN. Okay, step B, we're going to put a management address on this one. You don't have any addresses yet? Well, how about show IP interface brief? Oh, he has some address. I need to, oh, he got it from DHCP. Oh dear, I have to blow that away. Okay, I was testing it earlier just to make sure. I need to delete that, otherwise that might mess us up because he only allows you to do one. So I'll go to interface VLAN 1, no IP address, and do a shutdown because we're not going to use that one. If I do show IP interface brief again, okay, VLAN 1 has nothing. We're going to create the other. We're going to create the other management VLAN. Okay, so where was I? I'm on step S1 VLAN 200. So S1, we'll go to configuration mode, interface VLAN 200. IP address. Oops, I got my caps lock on. IP address is 192.168.1.66, and that weird subnet mask again. And then shut down. And then let's do the default gateway command because we need to do that just like on a workstation, a regular host machine, so he can communicate with the networks. Otherwise, he would only be able to communicate on his own local LAN. Mode and IP default gateway is 192.168.1.65, and that's his default gateway port on the router that he sends his information to if he needs to talk to somebody else. Okay, I'm going to do it right on this. Now on S2, what do we have to do on S2 then? I messed something up earlier. Oh yes, now we're going to do step C, slightly above halfway on page 6 on S2. And I'm going to go to interface, VLAN 1, the default VLAN, very minimal configuration on S2. IP address is 192.168.1.98. 5.255.255.240. You're going to freak here because I did something earlier. Okay, let's shut down. And then let's do this default gateway. IP default gateway for switch 2 is 192.168.1.97. Okay. Let's see now. I'm going to just do the. I'm going to skip this interface range and turning off all the other ports. I'm just going to do step 8, and in the interest of time, and just assign port 6 on this first switch and port 18 on the second switch to the VLANs they need to be in. The rest is left, as they say, as an exercise for the student. Okay, so I'm going to jump to step 8. the A dot step, which is near the bottom of page 6. I'll go to configuration mode, and I'll go to interface fast Ethernet 0/6, which is traditionally is our PC-A. Port, mode, access, just to make sure it's, you know, it wasn't trunking or something. And then switch port, access, VLAN, and he's going to be 100. Okay, check to make sure that took. We'll do a show VLANs. And look, the 100, the PCA is in the client subnet, and he's assigned to port 6. So that should give us connectivity with PCA later on, if I didn't make some other horrible mistake. Port 5, you notice that answer to step 8 in the middle, top above the middle of page 7. We left port 5 alone because port 5 is going to connect to the router. Both switches are going to, port 5s are going to connect to the switch. One's going to connect port 5 to the router. Switch 2 is going to connect his port 5 to router 2, and they're going to be trunking. And what if we need that trunking? Okay. Well, in this case, I think it's just switch 1. Okay, now we're going to manually configure. Oh, he's going to manually configure something. Oh, good. That's the insider guru way I like to do. I don't like to trust these dynamic desirable and dynamic auto and ether channel active and all these other things. I like to do on to do that stuff and prove that it works okay in this app. And another safety feature is if you do dynamic desirable or something on a port that goes into like a help desk area, that gives that person the ability to trunk up to the switch and see all the network stuff he shouldn't see. Okay, so if we do a show interface status now, port 6 has been assigned to VLAN 100. Now we're going to take that port 5 and we're going to make him a trunking port. What we're going to do here. So configure terminal, interface, fast Ethernet 0/5, switch port, mode, trunk. Yes, ma'am. No, the electricians are here working.
Oh, so they're working.
Yeah, the electricians are doing some system, safety system.
I just did not want it to be open. I did not know if you were using it. Thank you.
So switch port, more track. Oh, let's set the native VLAN. Otherwise I get pesky error messages. So I'm still on port 6. I should be able to say switch port, trunk. That's incorrect in the lab, but the prompt is incorrect. Native VLAN 1000. Okay, and which VLANs are allowed? Switch port, trunk, allowed, VLANs 100, 200, 1000. And then save the configuration to the switch. Now we should be able to verify this, but the official command is, the switch is taking a long time to save. I think I blew his mind when I did that configuration earlier. I really should have done a write erase and a reload. Okay, so show interface trunking, and port 5 is trunking to the router. Okay, good. And the other command, which I like better, show interface status. Port 5 is trunking. This does not work in packet tracer. Packet tracer will report that it'll work. It'll bounce. It'll ping. But when you type show interface status, the output of the show interface status command in packet tracer is incorrect. It'll show all the ports as VLAN 1, no matter what you do to them. It'll work as if they were done properly. Show switch port, switch or more show interface trunking works on packet tracer. Okay, what IP addresses would the PCs have if they were connected to the network using DHCP? Well, we looked at that. What were their addresses? We'll do it one more time here. 169.254, let's go to PCB. 169.254. something. We haven't set up the DHCP yet. Once we set up the DHCP, the router should assign it to the host machines. Okay. Now we're going to configure 2 pools because we have 2 networks. We have PCA subnetwork the PCB subnetwork. We need to configure 2 DHCP servers on the router, and that way he can give the addresses to both of them. And you can do this. You can have as many subnets as you want. I think there's a limit of like 6,000. Okay, so I need to go back to the first router and the second router. Oh, I got a swing bar. By the way, you could do this on a switch. I did this in the lecture the other day. Switches, our little dinky 500 switches can actually be a DHCP server too. Same exact command structure. But I'm going to do what the lab says. So I'm going to swing my wires over to R1 and R2. Sorry about the AC. No one else is coming to cramp us. They're trying to say, yeah, we got $825 million from the taxpayers, but they can't run the airport. And we're waiting for word. So they're supposed to tell us in early October. What's happened in the spring? Will everybody come back yet? Okay. Okay, so I'm near the top of page 8, and we're going to configure these 2 DHCP servers, and I should be R1 now. Oh yeah, that's right. I put passwords in this. I should be R2. I think in the interest of time, I didn't do anything on R2. Okay, so let's exclude 5 addresses from the first pool, and these would probably be addresses you would be the default gateway and the switch management address, and maybe a server and a printer, something like that. So I'm going to go to the config mode. Oh. Look, I mistyped the command, and instead of being stuck in limbo for like 2 minutes while it tries to do a DNS lookup of a name you mistyped, and you're sitting there, oh, come on now, come on now. It immediately put me back. So that's the advantage of doing the no IP domain lookup. Okay, IP, DHCP, excluded addresses, and they're going to be 192.168.1.1 through 192.168.1.5. Now let's create our IP DHCP pool. I'll call it, he's going to call it R1 client LAN. I didn't spell that correctly. Oh dear. Doesn't make a difference what the name is. Just got to be unique. Okay, now we're in the DHCP config mode, and we're going to specify, well, what network are you going to look for to assign addresses from that pool to those guys that are connected to that interface network. 92.168.1.0, 255.255.255.192. This is one of those commands you're supposed to be able to use a slash number instead. I don't think it worked on Packet Tracer. Okay, what's our domain name? How about tccd.edu? The one he gives. Default router. That's the default router for all the guys that are going to get this DHCP address. 192.168.1.1. I'll go ahead and do. He didn't do this. I'll do this. What's the DNS server going to be? I like the Quad 9 one because it filters out malware sites instead of a regular open DNS server that will connect you to anybody, even if it's in the Ukraine or something, and it's going to try to mess with your computer. And the least time, and normally it's going to be 1 day, but we're going to make it 2 days and 12 hours and 30 minutes. Now let's see what's our topology. R1 connects to PCA. Just curious here, I'm going to check if PCA has gotten an address yet. So I'll go to PCA. Hasn't got an address yet. Okay. And check, show off the interface brief. All our ports are up and up that should be up and up. Okay. Now we're going to configure the second DHCP pool for the second one on R1. So we'll go to the global config mode, and I'm sort of slightly below the center of page 8 now. So in this particular pool, IP DHCP pool excluded addresses is going to be from 192.168.1.97 through 192.168.1.101. And that's about 5 addresses, isn't it? IP DHCP pool R2 client LAN. Put the client correctly that way. It doesn't matter. Like we said, it doesn't matter. Network 192.168.1.96, 255.255.255.240. Okay, what's the default router for this guy? 192.168.1.97. Main name, TCC. NS, quad 9, and then lease time, 2/12/30. Do a save a configuration. Okay, step 3, we're going to type some show commands to see what's going on here. So show IP DHCP pool. What's the pool that I created on that? Well, I created 2 pools. One was a 192.168.1.1 through 62. We excluded the first 5 addresses. The second pool, our 2 pool, was 190.97 through 110. And we stole some of those addresses and reserved them for, fixed network devices like servers and routers and printers and stuff that are normally, you want them to have the same address every time. Okay, show IP DHCP bindings. What addresses has he been given out? He ain't given out no addresses yet. Show IP DHCP server statistics. And that gives you, oh, well, it doesn't look like he's having traffic at all here. He's got 2 pools. He hasn't received any DORAs, discover, offer, request, acknowledge. Nothing's happened yet. Attempt to acquire an IP address from DHCP on A. Well, what's going on here with A? It should have gotten an address by now. Let me go back to A. And I'm going to do ipconfig coffee. Config /release. And renew. I tested the connectivity earlier here. Oh, look at that. So on the Windows PC workstations, particularly VMs, VMs are very treacherous and tricky in that sometimes it's something that works perfectly well with a physical machine. When you're on a VM, you may have to disable and re-enable the interface port. If it's a DHCP, you might do the ipconfig release, ipconfig renew, so it grabs the new address. So it looked like it grabbed the address here. Can I ping my default gateway? Yeah, I can ping my default gateway. Okay, so I've got network connectivity to everywhere. Now 2 is on the other router. We haven't configured this relay address, this DHCP relay address, because PC-B, let's see what's going on PC-B. Oops, no. I clicked cancel by mistake. Sorry, I meant to go ipconfig. Okay, that's a duplicate address here. Well, we haven't configured an IP DHCP relay yet, so we're going to fix this. Okay, so I'm going to configure R2 as a DHCP relay agent. So I'll go back to term, and I'm going to R2. I'll bring up both of them so we see both of them. Show IP interface brief. Everything's up and up. I didn't forget nothing. Okay, so I'm near the top third of page 9 of the lab, and we're going to go to R2, and we're going to go to the configuration mode and go to interface. Give it 0/1, not G001. IP helper address is what he's going to do. This is going to tell R2 to convert that broadcast, discover broadcast from the PCB. Broadcasts do not survive TCP routers. Routers kill broadcasts. Switches flood them. Routers don't like them. We don't want our broadcast from the printer to be ever on the internet. That doesn't make any sense. So we need to tell the router, if you receive a port 67, port 68 DHCP request, convert it to a unicast using this IP address I'm fixing to type. And that way it can go through the other routers and get there. 10.0.0.1. That's the IP address of R1. Remember, R2 was 10.0.0.2. We pinged between 1 and 2 and they worked. And they were supposed to route the configuration. Okay, now let's go to our troublesome VM. And what I'm going to do is ipconfig/release. And then I'll do renew. It got an address. Can he ping his default gateway? Okay. So it seems to work. Oh, open a command prompt, the renew. Okay. Let's go to R1 and show the bindings. So he's got a binding there for that one. What was the other one? Show pool. So it seems to be working okay. And that's the end of the lab. So let me stop recording.